Hello everyone, we are back today with a new video, a new topic, a new subtopic of topic numbers, and subtopic is integers, where we have to learn about prime factors, common factors, and common multiples in specific. And as this topic is related to some other topics like HCF and LCM, so we are going to learn that as well. And also we are going to review some of the previous topics, that are the factors and multiples, which we have discussed in detail in the last video. So you can check that out first if you are still not clear about them. Let's start. First thing is, what are factors? As discussed in our last video, factors are actually the smaller numbers that when multiplied, like a pair of factors when multiplied give you your original number. Okay, so all the numbers that when multiplied by some other number to give you an original number, these all numbers are called it factors. So as we gave you an example previously as well, like 8, so all the smaller numbers that will divide this 8 will be its factors. For example, 1, 2, 4 and 8, the number itself. These all are factors of 8. Now let's talk about multiples. So multiples are actually when we are going to multiply any number with natural numbers 1, 2, 3, 4, 5 up to so on, so we get its multiples, or we can say the table of a number gives you its multiples. So 8 is a multiple of itself, and 8 2 is 16, 8 3 times is 24, 32 and up to so on. These all are multiples. So this is like the basic concept. For more details you can check the previous video. Okay, then we have to talk about what are prime factors. Okay, we also have learned in detail about what are prime numbers, so you can check the same video number system for all this. Okay, what are prime factors? For that we need to think about prime numbers. Prime numbers are the numbers which are only divisible by two numbers, 1 and the number itself. So prime factors means those factors that are only divisible by 1 and the number itself. So in the above example, let's discuss. 1 is not a prime number because it doesn't have exactly two factors. It has only one factor, that is 1, and the number itself is also 1. Okay, 2. Yeah, 2 is a prime number and is a factor of 8, so 2 will be a prime factor. And 4 is a factor, but it is not a prime number, so it won't be a prime factor. Same is the case with 8. 8 is a factor, but it is not a prime factor. Okay, so we have discussed this. Let's take one more example. For example, you have a number, a very interesting number to understand factors, multiples, is 12. So it gives you information about most of the things. So what are the factors of 12? 1, 2, 3, 4, 6 and 12. Okay, now what are the multiples? 12, 24, 36, 48 and so on. Okay, so from these, in the first case we just had, okay, it should be downwards because we need to address the prime factors separately. Okay, fine. Let's discuss about your number 12. If you have a number 12, so what are its prime factors? Prime factors are actually the factors which are prime numbers. So let's think about them. 1, no, 1 is not a prime number. 2, yes. 3, yes. Not 4, not 6, not 12. Okay, so only 2 and 3. The rest are not prime factors. So I'm writing a simple definition for your later understanding that what are prime factors. Factors that are prime numbers are called prime factors. Factors that are prime numbers are called prime factors. Okay, so we have discussed what are prime factors. Now, how to get prime factors? To get prime factors, we have a we call that process, that method is called prime factorization. So simply also get a definition of prime factorization. The method to find prime factors is called prime factorization. Or process to find prime factors is called prime factorization. Okay, uh, these are just for your understanding. These definitions I'm writing for just for your understanding. Okay, now there are two methods to find prime factors, and that are, one is tree method and one is division method. Okay, what is actually this prime factorization means? If you continue to factorize a number until you get only the prime numbers, this is called prime factorization. Okay, if you continue to factorize a number, if you continue factorization until you get prime factors, it is called prime factorization. Okay, good enough. This is another way to define prime factorization. Okay, now let's talk about the definitions, or like the two process. So first we are going to discuss why tree method. For example, let's take any number. Let's take 8 and 12 that we have discussed now, and then later on we'll talk about some more examples like some higher numbers. Okay, first step of prime factorization, it is not necessary for you to just make it into half, but it will make your division easier, your prime factorization easier if you first divide it into half. Like 2 times 4 is 8, so we are going to write these are the two factors, two numbers that multiply to give you the original number are its factors. So we are writing the factors like this. Okay, 2 4 times is 8. Now see, this is actually your prime number, so this is your prime factor. Now 4 is not a prime factor, so we will factorize it further. How many okay, how can you divide it into two numbers? Like which two numbers multiply to give it 4? Yes, 2 times 2. So see, now this is the way we are getting the prime numbers. So we got all the three prime numbers, so our prime factorization by tree method is completed. Now you can write its prime factors as we get the factors of 8. See, originally what are the factors of 8? Factors of 8 are 1 2 4 and 8, but these are not prime factors. If you continue to factorize until you get all the prime numbers, it can be 2, it can be 3, it can be 5, 7, any prime number. But if you get all the prime numbers at the end of the factorization, then it is actually your prime factorization is done. So prime factors are 2, 2 and 2 in this case. Okay, now let's talk about the 12, number 12. I told you, yes, you can do. See, it can be the two factors of 12 can be written as like a pair of factors is 3 and 4. Okay, so you can do this as well. It's completely all right, but I prefer breaking it into two halves by like writing one factor as a 2. Mostly it helps us, or 3, or any smallest factor that could make the bigger number into a very small part. So trying to find the smallest prime factor in the first step will just break it into a very small number. You'll understand this when you'll practice it more with different numbers, so it makes sense then. So I'm doing it with a pair of factors 2 and 6. So this is your prime number. So here the factorization ends in this part of the tree, or this part of the branch of the tree. Here it will continue because 6 is not a prime number. So 2 3 times is 6. Now 2 is also a prime number and 3 is also a prime number. So our prime factorization ends here. So now you will write prime factors as 2, 2 and 3. Good one. Okay, let's try this method for some bigger numbers. Let's think of a number 40. Okay, 40 will be broken into two parts like I do normally. I use a number 2 220 times is 40. Then you have 210 times is 20. Then we have 5 times is 10. So this all is giving you. Now prime factors that you get is this. Okay, now you can write its prime factors. Prime factors are 2 3 times and 5. 2 okay, now I'm doing a bigger number, like I'm taking a number 65. Okay, now it is not an even number, so we cannot divide it by 2, so I'm breaking it with a 5. So 5, how many times is 65? Yes, we see that there is a 5, so 65. So number ending with 0 and 5 are divisible by 5, so I'm doing that. 5 13 times is 65. Oh yeah, it is not a bigger one. See, in the first step we get the factors, because though both are prime numbers, so prime factors in this case are 5 and 13. Okay, let's try one more question and one more example. Just like you have a 60, so 230 times is 60. Then you have 30 is not a prime number, so it will be factorized further. 215 times is 30. 15 is still not a prime number, so it will be factorized. 5 3 times is 15. This is the step where we are getting the prime factors, and no number is left that is not a prime number. So prime factors of 60 are 2 2 3 and 5. Okay, fine, this is your tree method. I hope you get it, how to break a number into its prime factors. Okay, now the next thing that we should know is division method. And we mostly use division method because it is very convenient. So let's think about the division method. In division method, we do repeated division of a number until we get our prime factors. Okay, so we are going to take the same examples of 8 12 40 and 65 60 to show you how these both procedures work. So this is your grid. Okay, good one. Okay, your grid is completed. I just wanted to make one grid so that we can use that again and again. Okay, so your first number is 8. We won't be needing a bigger one. So 2 4 times 8, 2 2 times 4, 2 1 times 2. See, this is how you are going to get prime factors by repeated division. So your prime factors by division method give you 2, 2 and 2. Here the numbers that you get are actually your prime factors in repeated division method. Okay, so see, in your 8th thing, the prime factors that you get by tree method are also the same. Now let's do for 12. To 6 times 12, to 3 times 6, and then we are left with 3. So 3 is only divisible by 3. So 3 1 times 3. So we got our prime factorization here. Okay, and see what are prime factors. We get the prime factors here, 2, 2 and 3. Okay, next is the digit that we used is 40. 20 times is 40. 10 times is 20. 5 times is 10. And 1 times is 5. So here by prime factorization method, the prime factors you get are same as you get in case of like in tree method as well. So your prime factors are 2 for 3 times and 5. Okay, this is your repeated division method for 40. Then we have 65 and 60. So let's try that as well. Okay, 65, 60, and let's take any other number, 120 say. So as to check how to find prime factors by repeated division. So 5, 1 times is 5, and then see, this is 1 times is 5. Then if you like divide it 65 with a 5, so 5 1 times is 5, then you are left with 1, and then you take 5. So see, 5 1 times 5 and 1 is left, so this digit with this one becomes a 15. So 5 3 times is 15. So here you are doing 13. So every time here comes the quotient because you are dividing it at each step. Okay, some initially if you find it difficult to divide, so whatever number with which this given number is divisible, so you can divide it separately and write the quotient in the next line. Later on you would be able in a position to do all this manually in your head, and you can find your factors easily. Okay, now 13 is a prime number and it is only divisible by 13, so this is your prime factor. Okay, now let's do 60. 2 3s are 6 and 0, so they 3 to 30 times is 60. 2 1 times is 2, see, and 1 is left here, and with 0 it becomes a 10, so 2 5 times is a 10. 5, then you can either first divide it by 3 and then 5, or 5 or 3, it doesn't make any difference. So 5 3s are 15, and then 3 1 times is 3. So these are your factors. Now let's take an example of 120. So 2 6 are 12 and 0. 2 3s are 6, 0. 2 1s are 2, 2 5s are 10, 3 5s are 15, and 5 1s are 5. See, this is how you can find the prime factors in each case. So prime factors are 5 and 13. For this case, prime factors are 2 2 3 5, and here prime factors are 2 for 3 times and 3 5. Okay, this is your division method. So let's get back. We are done till here. Okay, now comes the real thing. Common factors. What are common factors and what are common multiples? So as we are talking mainly now about the factors, so let's talk about that first. Common factors. Common factors, this term comes into being when you are comparing the factors of two numbers. For example, you have factors of number 60 and you have factors of number 120. I'm talking about prime factors. Okay, prime factors of 120. Okay, right from here, prime factors of 60 are 2 2 3 5. You can find it by any method, by tree method or by division method, and you will write them down. And the prime factors of 120 are 2 3 times and 3 5. Okay, when we talk about common factors, it actually means which factors are common. So here in this particular case, common factors are that are common in both are 2 for 2 times and 3 and 5. Okay, this is what we call as common factors. Okay, now let's take some other example as well. Let's take an example of number 12 and 40. If they ask you what are the common factors of 12 and 40. So here was a comparison between 60 and 120. Now we are comparing 12 and 40. So first write the prime factors of each. You can find it by any method, the prime factors. Okay, what are the prime factors of 12? 2, 2 and 3. Prime factors of 40 would be 2, 2, 2 and 5. Okay, in this case, can you see, are there any common factors? Yes, 2 and 2 and 2 and 2. So this is called common factors are 2 comma. I'm writing right now in by separated by commas. Okay. If you got this common factors, so now the concept of HCF is very easy. Now we get to an important concept that is actually the important thing for which we are learning all this. What is an HCF? HCF is actually product of common factors. Okay, product of common factors is your HCF. Okay, now we will talk about all the numbers that we have learned about up till now, like the common factors that we found out. So HCF of 60 and 120. 60 and 120 is common factors are 2235. 2, 2, 3 and 5. So 2, 2, 3 and 5. Common factors of 60 and 120. So HCF would be, I'm not telling you up till now, I haven't tell you what is this abbreviation of. I'll tell you, just give me 1 second. Let me complete this, then I'll tell you about this. HCF, what is HCF? The product of common factors. So your HCF would be 2 times is 4, 4, 3 times is 12, and 12 5 times is 60. Okay, so HCF is going to be 60. Okay, what is this HCF pronunciation, like the abbreviation? HCF is an abbreviation of highest common factor. Okay, so let's write that also. Highest common factor. Okay, when we are dealing with the two numbers for which we need to find the highest common factor or HCF, we will multiply all of its common factors. It will give you its highest common factor. Okay, let's do apply this on your second example as well, like 12 and 40. If they ask you about HCF of 12 and 40, so first you'll write Okay, sorry, some of the things were erased. No problem. Okay, common when we need to find the HCF of 12 and 40, first we need to find write the common factors that we found by tree method or by division method. So common factors of 12 and 40, 12 and 40 common factors are 2 and 2. So 2 and 2. So what would be your HCF? Your HCF would be the product of its all common factors. So product would be equals to 4. This is your HCF. This is how you find highest common factor of any two numbers when you multiply all the common factors. Okay, this is your HCF thing. We are only left with one thing, that is actually common multiples and LCM. So let's discuss first common multiples. I'm reviewing this, that multiples are actually the bigger numbers that we get when we multiply a number with any number, with any natural number, 1 2 3 4, any number. When we multiply it, the bigger numbers that we get are its multiples. So let's talk about what are common multiples and how do we find it. Okay, common multiples, the one way of doing common factors and common multiples, there is, yeah, there is one way of finding common factors and common multiples, and this is listing method. You can just simply multiply numbers to write, like if you have 8, so you can find its common factors by multiplying 2 times 2 times 4 and 2 times 8. So you can do it by listing method as well. In common factors thing, it is not a very good way to do it, because we need prime factors. But in case of multiples, you can do it. For example, if you need to find the multiples of 6, so 6 is a multiple of 6, then 12, then 18, 24, 30, and so on. So writing the multiples is easy. You just write the table of the number, or you just multiply it with 1, then 2, then 3, then 4, and you will get the multiples. Now I find the multiples of some other number, because the thing that we need to learn is common multiples. And common multiples, we need to find common multiple when we are comparing the multiples of two numbers. Okay, so multiples of, for example, 12, or let's say 8. 8 is a multiple of 8 because 8 1 times is 8. 16, 24, 32, and so on. Okay, the one way that I'm telling you is to find common multiples is to by listing. We are listing down the multiples now, just by using table. So these are your common multiples. These are your multiples. If you want to know about common multiples, you need to check which are numbers are common in both. Okay, now 12 only like the multiples that we wrote, we only wrote 4 to 5 multiples. So out of them, the only common multiple is 24. If you list down more, so you may get some more as well, like for example 30 and then 36, 6 6 are 36, 6 7s are 42, 6 8 times is 48. Okay, now write some more multiples of 8. 8 5 times is 40, 8 6 times is 48. See, when we wrote some more multiples, we get one more common multiple, and that is 48. So what are common multiples from the multiples that we wrote? 24 and 40. Okay, so there is a term, after getting common multiples, we need to know what is your next thing, that is LCM. Let's talk about it. This is another important thing, like HCF, that is very much used, and actually we are learning all this because we need to learn what are actually HCF and LCM. That is very much used in mathematics. So LCM is actually the abbreviation of least common multiple. Okay, and what is it, least common multiple? How do we get it? I'll write its definition later. How do we find it? By listing method, we find it. See, when you write the common multiples, which one is the least or the smallest common multiple? 24. So if you list all the or some of the multiples of a number, and then you write down the common multiples, out of them the smallest common multiple is your least common multiple, or LCM. There is another way of finding LCM, and that is by division method. The same division method will be used to find the least common multiple. I'll show you how, using the same grid or the lines to find it out. Okay, division method says, okay, we need to find the LCM of 6 and 8. So how do we do it? We are writing 6 and 8, both the numbers on our grid, and now start dividing it. 2 3 times is 6, to 4 times is 8. If a number can divide both, you will divide both the numbers in the same step. If only one, like there is nothing common between 3 and 4, so only one number cannot divide it. If you will take 3, it won't divide 4. If you will take 2 or 4, it won't divide 3. So at this step, what you will do, you can take any one number that will divide one of the numbers, divide that and leave the rest, like take the other number as it is below. Now when you'll get 1, the division stops here. Now you are going to divide this number. So 2 times is 4, and 1 times is 2. This is how your division method for LCM is done. Okay, division method is done, but how do we get LCM? LCM will be product of all of these numbers. that are common and also uncommon. See, here 2 was a common factor for both, but these all are not common. So 2 times 3 times 2 times 2. So 2 3 is a 6, then 6 2 is a 12, and 12 2 times is 24. So our least common multiple of it is 24. Okay, so what is actually the definition of LCM? As it was in the HCF, the product of common factors is HCF. In case of LCM, product of all common and uncommon factors is LCM. Okay, so what is LCM? Product of all common and uncommon factors is LCM. This is it. I hope you understand it. If you want to find the HCF of 6 and 8, you will just multiply the common factors. If you want to find the LCM, you are going to multiply all the common and all the uncommon factors. So this is how it goes on. I hope you get it. I have done this HCF thing, like for HCF I have calculated the factors separately, and then I listed them, the common factors, and then I choose the just multiplied the common factors. You can directly do the HCF and LCM. Let me give you a comparison between an HCF and LCM. If you want to do it by same method, so what will be the difference? Let's take example of 8 and 12, 8 and 12, and we need to find the HCF and LCM for these two numbers. So taking your grid for both, and we will write the numbers in the grid, 8 and 12, 8, 12. So let's divide it for HCF, highest common factor. So first find the common factors. So 2 to 4 times 8 to 6 times 12 to 2 times 4 to 3 times 6. See, now you get all the common factors, and now if you will divide it, so only one of the numbers would be divisible, the other number cannot be divisible. So you are going to stop this division here, and the common factors that you get are only these 2 and 2 that are written here. These are the only common factors because these only two divide both 8 and 12. So your HCF would be product of all the common factors. So your HCF would be 2 times 2 and 4. Okay, highest common factor is 4. Now let's see if for the same numbers we need to find LCM. For LCM, what do? You'll start like same, 2 4 times 8 2 6 are 12, 2 2 times 4, 2 3 times 6. See that now the common factors are ended. Now if you are going to take any number, it will only be dividing one number. So 2 1 times 2, 3 as it is, and 3 1 times 3. Now the factors that you are getting are not only the common factors but the uncommon ones. And what is LCM? According to definition, LCM is actually the product of common and uncommon factors. So it will become 2 into 2 into 2, 3 times 2 and 3. So it will become 2 2s are 4, 4 2s are 8, and 8 3s are 24. So this is your LCM. This is the difference between HCF and LCM. HCF is product of common factors. LCM is product of all common and uncommon factors. I hope you get all of it. You understand each and everything in it. We have covered everything related to factors, multiples, prime factors, prime factorization, common factors, common multiples, HCF, LCM, both, all of them. Hope you understand everything. Please do tell us in the comment section if you have any questions, any queries, any suggestions. Thank you very much, and Allah Hafiz.